Let's look at one last example. Suppose we want to solve the initial value problem. dy dx is 2x minus y over 1 plus x, and y of 1 is 2. This is an old exam question. We're first going to rewrite the equation in standard form. Y prime, separating that fraction on the right, is 2x over 1 plus x minus y over 1 plus x. And we should bring the y prime and the y term over to the left and make sure that the coefficient of the y prime term is 1. So in standard form, this becomes y prime plus y over x plus 1 is equal to 2x over x plus 1. Here, p of x is 1 over x plus 1, the coefficient of y, and q of x is the function of x on the right-hand side. It's 2x over x plus 1. So we apply our method. We first find the integrating factor, which is e to the power of the integral of px dx. And now the integral of 1 over x plus 1 is the natural log of the absolute value of x plus 1. And e to the power of the natural log of the absolute value of x plus 1 is just the absolute value of x plus 1. And this is either x plus 1 or minus x plus 1. And the next step in our method is to multiply across by this integrating factor. And it doesn't really matter whether we multiply an equation by plus x plus 1 or minus x plus 1. The minuses will cancel, so it's all the same as multiplying by x plus 1. So let's just multiply our equation by x plus 1, and we get x plus 1 times dy dx plus y is equal to 2x. And remember, the left-hand side is going to collapse to the derivative of the integrating factor times y with respect to x, and the right-hand side here is 2x. Next step is to integrate both sides with respect to x, so we get the integral of the derivative of x plus 1 times y on the left equals the integral of 2x on the right. And of course the integral of 2x is x squared plus some constant, and on the left-hand side, because the integral and derivative are inverse operations, it's x plus 1 times y, plus some constant, but we can roll that constant into the constant on the right. So now we want to solve for y. We divide across by x plus 1, and we get y equals x squared plus c over x plus 1. And now we can figure out what the c is from our initial value. We have when x is 1, y is 2, and plugging this into the equation, we get 2 equals 1 plus c over 2, and in other words, c equals 2 times 2, which is 4, minus 1, which is 3. So our solution is y equals x squared plus 3 over x plus 1.